Hi students, this is Miss Johnson back with more on 4-4 parallel and perpendicular lines. You can go ahead and just continue on your notes from the day before when we talked about parallel. Alright, we are just going to do one example. It's example 2, continuing from the other day. We are going to write an equation in slope-intercept form for a line that's perpendicular to 2x plus 3y equals 12. That's in standard form. And it has to go through the point -4, 6. So here is our line that represents 2x plus 3y equals 12, and it needs to go through the point -4, 6. So it needs to go through this point right here. So I kind of tried to show what these perpendicular lines would look like. And again, I'm sure this is really how they lay out roads so that you come to a 4-corner stop or stoplight, and you want to make sure that they are perpendicular. Alright, we have 5 steps that we're going to go through. And step number 1 is we need to find the slope. We are not given the slope. We need to find the slope by rewriting the equation from standard form to slope-intercept form. So, our equation in standard form was 2x plus 3y equals 12. To get it into slope-intercept form, we need to have the y all by itself on the left-hand side. So, we're going to start off by subtracting 2x from both sides. Then we will be left with 3y equals -2x plus 12. Now to get the y by itself, we need to divide everything by 3. And when we divide everything by 3, we get y equals, and we can just leave this as a fraction, -2/3 x plus 12 divided by 3 is 4. Alright, now that we have our equation in slope-intercept form, now we know what the slope is. So to work with perpendicular, we are going to work with the opposite reciprocal of the slope. So if our slope for this line is -2/3, the opposite reciprocal is, instead of going to be negative, it's now going to be positive. And the reciprocal of 2/3 is you just flip-flop it to being 3/2. And it is okay to leave this as an improper fraction. Alright, now that we know what our slope is supposed to be, or I should say our opposite reciprocal, now it's just like working with the parallel lines, just like we did before. So we're going to start with point-slope form, because now we know our slope and we have our point. So we're going to work with y minus y1 equals m times x minus x1. So, filling in what we know, we're going to fill in our point and our opposite reciprocal. If we fill in our point, we've got y minus y1, where our y1 value is 6, so we'll have y minus 6 equals, our m is our slope, but we are working with the opposite reciprocal, so we're going to put 3/2 in for our slope, then our parentheses x minus, and our x1 value is -4. So it's going to be x minus -4. But we know that subtracting a negative means adding a positive. So we can just put the plus. Then our last step is we need to manipulate this into our slope-intercept form. We need to get the y all by itself on the left-hand side. First thing we need to do is we need to distribute the 3/2 to get rid of our parentheses. So we're going to distribute 3/2 times x to get 3/2 x, and 3/2 times 4. Well, let's work this one out. 3/2 is going to be 3/2, and if we're multiplying by 4, remember that means 4/1. And we get to multiply straight across. 3 times 4 is 12, 2/1 is 2, and 12 divided by 2 is 6. So that's where this 6 came from here, 3/2 times 4. Then we need to get the y by itself, so we're going to get rid of the -6 by doing the opposite of adding 6 to both sides, and we end up with y equals 3/2 x plus 12. So that's the equation of this line that is perpendicular to our given line, and it goes through the point -4, 6. So y equals 3/2 x plus 12. Thanks for tuning in. This is Miss Johnson, over and out.